Okay, previously we have already discussed linear regression. We have gone through all the processes, starting from preparing the data until we regress the data as a linear model. However, linear regression is not the only model that we can use. There are many other types of models. Um, we are going to discuss a few more, and another model that we are going to discuss in this session is what we call as a Bayesian network. Okay, so Bayesian network works based on the conditional probability theorem. I think you know what conditional probability is, but anyhow, to start discussing this Bayesian network, we will briefly discuss first about conditional probability just to refresh our memory on it. Okay, let's start the discussion from reviewing what probability is. I think you know this. You have learned it from many years ago. So if we have an event A and then you want to identify the probability of this event A, how we calculate it, it's very simple. You just have to count a number of these times A to occur divided by number of time trials. So just a very simple illustration of it. If you want to count the probability of number 5 appears when you throw a dice, the probability of number 5 to appear will be equal to 1/6. Okay, because there are only one number of number 5 in 6 faces of dice, and there are 6 faces of dice. So the probability of number 5 to occur will be 1/6. And then now let's take a look of a two event case. Let's say if I have two events A and B, I can derive a conditional probability. Let's say conditional probability of event A occurs given of event B. As you can see in this equation in this slide, the probability of event A given event B will be equal to the probability of event A and B occurring at the same time divided by probability of event B. So just an example of it, let's say if we have 85% of employees having health insurance in a company, let's say, and out of these 85%, 45% of it had a deductibles higher than $1,000. What percentage of people had deductibles higher than 1,000? In that case, then let's consider 85% of employees having health insurance as event B, and 45% of this 85% is the event A given of event B, because the 45% out of this 85% will be the an event inside another event. So the event A given of event B is 85% out of this 85%. So in this case, if we want to calculate what percentage of people had deductible higher than $1,000, you have to calculate the probability of event A and event B occurring at the same times. Okay, so in this case, then probability of event A and event B will be equal to event B, which is 85%, times event A given event B, which is 45%. Okay. Event A and B are disjoint if they cannot occur at the same time. So the previous example, when we are talking about insurance of a company, the one that we just visited, we have an overlap case, right? Event A and event B, they have a joint or mutual, there is a mutual inclusive in that case. But there are some cases that event A and event B are totally independent. This is where we have a disjoint case. When we have a independent probability case, these two events will not overlap to each other. This is the case illustrated by the right figure here. Okay, this is a case where we have disjoint events. Let's go back a bit to discuss this conditional probability. We have already discussed before. Probability of event A given of event B here represents the probability of event A occurring after it is assumed that event B has occurred. Okay, so we have already solved this equation before. Probability of event A given of event B will be equal to probability of event A and B occurring together divided by probability of event B. Taking a case when we have independent events, about these independent events, we discussed it before. When two events are disjoint, when these two events do not have mutual overlap in it, we call it as a mutual exclusive. So if these two events are independent, then the probability of these two events occurring together will not follow the equation of this conditional probability. When we have independent events, the probability of event A and event B occurring together will be just simply probability of event A times probability of event B. So when we have a mutually exclusive case or independent events, the probability of event A given event B will be just simply equal to probability of event A. Okay,